Okay, let's start working through some of the problems on this test review for test number 2. I'm not going to do the trig identities for now. Let me just start with, on this sheet, it says problem 4. And let me take a few minutes and give you a fair amount of detail on how we go about solving a problem like this and explain what's going on. And then after that, I'll make another video where I do some other of these problems fairly quickly. So the ultimate goal of an equation like this here has a trig function, but I'm not really solving for the trig function. My ultimate goal is to solve for that angle. And just as a reminder, in these kind of problems, we're going to be working in radians for our measure of the angle. That's the solution. However, since we have a trig function here, what I like to say is it's really like a two-step process. The first step is I say solve for the trig function. In other words, in this case, I would try and get sine of theta by itself. And then once you get the trig function by itself, you actually solve for the angle. And what's interesting is in the instructions, they're really asking for two different kinds of solutions. They first say, give the solution in the general form. So they say the general form. And what that means is the angle theta is between between negative infinity and infinity, which means basically theta can be any real number. There's no limit to what theta can be. So in the general form, we need to somehow express the solution for every possible angle. That would be a solution. And then the second kind of solution, they limit it and they say, now actually just work up when the solution is between 0 and less than 2 pi. So now they limit it. In a few minutes we're going to talk about the unit circle. In a sense, they limit it to find all the solutions in one trip around the unit circle. So let's go back to solving this. Now I'm going to do a quick illustration here just to get you thinking, because sometimes when people see like these trig functions, they have a hard time thinking about how to solve for the trig function. What if I wrote almost the exact same equation with the only difference being instead of sine of theta, I just decided to write it as 2x plus 3 equals 2. Now if I ask you to solve this equation for x, I think all of you can solve it very easily. This is just a linear equation. The way we solve a linear equation is to get x by itself on one side. So I would subtract 3 from both sides, divide both sides by 2, and there's my solution. We're going to do the exact same thing as we try and solve for this trig function. So I will subtract 3 from both sides, divide both sides by 2, and now I determined that the sine of theta equals negative 1/2. This is what I call like solving the first part of the problem. We haven't really gotten the solution yet, because up here my solution is what is theta? What value of theta would make this equation true? What I've solved for here is a trig function. But what we need to do now is, once we have solved for the trig function, how do we go ahead and take the next step and solve for the actual angle? So what this is now asking us is, it's asking us find what angle theta if I get an angle theta, if I go take the sine of that angle, it needs to equal -1/2. Whatever angle works, that is going to be my solution to the initial equation. And I've said it in class a few times, but I actually probably should have said it even stronger. Really, the best way at this point to determine this angle is you need to be able to use the unit circle. You need to know those values. In your head right now at this point, I need to go and think to myself, if I think about the unit circle, since I'm looking for the sine of an angle, I'm looking for the value of y. You know, the unit circle are those special points, and each of those points have an x-coordinate and a y-coordinate. So since I'm looking for the sine of the angle, I'm looking at all those points, and I'm looking at the y-coordinate, and I'm saying, let me go find some points on the unit circle where the y-coordinate equals -1/2. So let me just, once again, just to try and make it very clear if some of you are still confused about how this unit circle works. The unit circle, we learned, we have these key points, the points on the axes, and then in each quadrant we have these three sort of key angles, and these are the angles that we learned, both the angle, and then we have to learn the x and y coordinate, because then if we know the x, y coordinate, then we know the cosine and sine of the angle. So for my specific problem, I'm looking for an angle where the sine of the angle is -1/2. Since the sine, once again, that means I'm looking for the y coordinate of these points. And I need to go and find if there are any points on here where the y coordinate is -1/2. And lo and behold, first thing I realize is, well, since it's -1/2, the y value has to be in quadrant 3 or 4. And then I remember that this point right here, now this point, the angle to get to that point right there, if I start here, once I go to the negative x-axis, that's pi, and then if I go on right here, I've actually gone 7 pi over 6. This angle right here is 7 pi over 6. And that point, the coordinates, the x is -√3 over 2, and the value of y is 1/2, and the y value is my sine. So since I know that this point, the y value of this point is -1/2, I know the sine of 7 pi over 6 equals -1/2. So 7 pi over 6 is going to be a solution. But then when I think about my unit circle, I think, you know what? There's actually another point on this unit circle where the value of y is -1/2, and it's actually over here. And this angle is actually 11 pi over 6. And that point, the x is √3 over 2, and the y is once again -1/2. There are actually two angles, two places on this unit circle where the value of y is -1/2, which means there's two places where the sine of theta is -1/2. So then I can also say the sine of 11 pi over 6 is also negative 1/2. So if I think so far just one trip around the unit circle, I have found two angles that become a solution for this problem. Two angles that when I take the sine of the angle, it equals negative 1/2. But now, there's still a few more things to consider. The first is, they ask for first the general form of the solution. In other words, when theta can be anything. And then, secondly, they ask for actually the specific solutions when the angles are limited from 0 to less than 2 pi. So let's think about what that means. So first of all, we have a pretty good idea when we look at the unit circle that we have two different angles that are going to be solutions. The 7 pi over 6 and the 11 pi over 6. But now we have to think about, could there be even more angles that would also be a solution? And in fact there are, and here's the idea. And we've talked about this before, but let's once again draw a picture to show you what we mean. Let's use the 7 pi over 6 solution to show you what else happens. So once again, if I start the x-axis, there's my 7 pi over 6 angle, and the sine of that angle is negative 1/2. So the idea is the angle 7 pi over 6 gets me to this place on my unit circle, which is where y is negative 1/2, so the sine of that angle is negative 1/2. But here's something we talked about you can do with a unit circle. How about if I start here on my x-axis and I start going around, but I don't stop at 7 pi over 6. I decide to go all the way around once. So at that point, my angle is 2 pi. If I go all the way around once, I've gone 2 pi. But then I keep going, and the second time around, I actually do stop at this angle where this is my x and y, where my y is negative 1/2. So what have I done? The second angle is also a solution. I went around the circle once, and then I stopped here, and I ended up back at this point. What have I done? That solution would be 2 pi, one trip around the circle, plus another 7 pi over 6. And if I turn this into a fraction, 12 pi over 6, I could say another solution is 19 pi over 6. In other words, the sine of 19 pi over 6 is also negative 1/2. Now if you think about it, in the theoretical sense, you could start going around the circle as many times as you want, and then if you end up stopping here, and you take the sine of that angle, it's going to be negative 1/2. There are, in a sense, an infinite number of angles where the sine is going to be negative 1/2. So how do we write that? When we go back up here, we take the 7 pi over 6 the first time around where I would stop to get my solution, but then I realize that I could start making trips around the unit circle, 2 pi, and I could do it as many times as I want. The way I write that is 2 pi times n, where n is simply an integer. It can be 0, it can be 1, it can be 2, it can be 3, and it goes on forever. Whatever value of n I pick and I plug in here, the angle I end up with is still going to be right here, and the sine of that angle is negative 1/2. And I can do the same thing for 11 pi over 6. I simply have to add 2 pi n. And this is what they're talking about when they ask for the general form of the equation, or they're basically saying find all the solutions for any value of theta. Theta between negative infinity and infinity. This is a general form. Now, the second part says, okay, now limit it to where theta, whoops, let's do it like this. Now they say, instead of the general form, where we have an infinite number of possible solutions, let's limit it to just one trip around the unit circle. There are a couple ways to get the solution. One, you can think about it, but secondly, the safest way is you actually take the general form of the equations and you start plugging in values of n, and the angle begins to grow, and you keep looking until all of a sudden the angle is outside of the 0 to 2 pi range. So let me do this up here just so we can see it. So what happens if I decide to look when n is 0? My first equation, 7 pi over 6 plus 2 pi times 0, theta just becomes 7 pi over 6. If I look at my second equation, when I set n equal to 0, the second term ends up being 0, and theta would be 11 pi over 6. So these are the two solutions that I get when I set n equals 0. What happens when I set n equal to 1? Well then, my solution for the first equation, if n is 1, I have 7 pi over 6 plus 2n, and earlier I did that before, and that equals 19 pi over 6. But if you look at it, 19 pi over 6 is larger than 2 pi. So all of a sudden I've got an angle now that's outside of the range I'm looking. I'm looking for 0 to 2 pi. So I say that is not going to be a solution. And then if I look at the second equation, 11 pi over 6 plus 2 pi times 1, or plus 2 pi, that's like 23 pi over 6. That's even larger. So that's not a solution. So basically, for 0 to 2 pi, these are my actual solutions. So once again, in these first equations, you're asked to give the general form. You have to include the 2 pi n part. And then for the second part, they say now go in and find the solutions just between 0 and 2 pi. All right, so let me stop now, and then the next video I'm going to do a few more of these equations, but I'll do them much more quickly and not have to explain everything.